Welcome to Reality Creative Video. I'm Hermes, and today I've been exploring high voltage AC plasma arc, and because it's new, and I want to get it working, get all the little quirks worked out with it, understand it, and see what the difference is between cooking a colloidal with a plasma arc as opposed to cooking a colloidal with low voltage electrolysis. And so that's what this show is about, my investigation. Titanium. So the guy in the forum cooks his titanium using plasma arc. And that got me into thinking. Now when I cook titanium in low voltage electrolysis, I have to use the gold formula, which is really intensive, chemically wise. And it destroys spent titanium rod, and this is a new titanium rod, and you'll see the difference between the two. The process, low voltage electrolysis process, and the chemicals make it look like it does in there, and while there's no taste in the titanium, I can only use this rod once or twice, and then I have to throw it away because the oxidation, I guess this is titanium dioxide, is so heavy on here that it won't cook properly after that. But titanium is cheap, so what I would normally do is I use this once or twice and then I toss it out. So that got me to thinking that, maybe there's a better way, being I have the high voltage AC plasma arc thing going, and it would be a good way for me to test the plasma arc setup without having to use my platinum, which is a precious metal. So titanium, if I mess up a piece of a titanium, I toss it away and get another one. I got a whole roll of titanium for like $15, so that wasn't a problem. And I wanted to see the difference between low voltage electrolysis titanium and high voltage plasma arc titanium. That's cooked with just distilled water in it. So that's what I endeavored to do. And I got high voltage AC plasma titanium here, and I got low voltage DC electrolysis platinum here. I can't say it cooked any faster. It took an hour with the plasma arc, and it was very tedious to get the plasma arc. You got to get the probes just right, and I would talk with my little high voltage $30 10 kilovolt transformer, which is basically, it's an electronic transformer, which is I think why it has trouble creating the arc. But once you get the arc going, it goes for a little while and then it'll peter out, and then you got to put the leads closer together. But it's all good experience because I'm learning how to create arcs. And the new top with the bracket, the clamps on here actually works really great, and I needed a way to test that out. So why not use the titanium? I could adjust it with the clamp down on the things, and when I attached the leads, it didn't move all over the place. This here, the spacing down here stayed absolutely perfect, and then I was able to keep adjusting until I could get that arc to happen, because it would only happen at a certain distance, and that was tedious enough. And then it would cook for a while, and then it would stop because you're burning the material at the end, and then you have to feed a little bit more material in. But as it got to the end, of an hour, it seems like an hour is about the most I can cook a plasma arc with this particular transformer. It doesn't have enough energy or juice, or maybe the protection circuit, and it won't let me create the arc when there's a lot of material in the solution. But an hour on the plasma arc really gives very dense colloidals. So here we got two pictures. One is low voltage. This one here on the microscope right now is high voltage titanium, but he also did have a picture of high voltage titanium and low voltage titanium, and I'll show them both over here. Now, I've been looking at colloidals for a long time, and I definitely think the high voltage plasma arc titanium looks superior. It's a lot cleaner. The particles are smaller and there's more of them. Even though we used less material on the high voltage plasma arc than I did with the low voltage DC. And I noticed that with platinum as well when I compared the differences between the low voltage DC platinum and high voltage AC plasma arc platinum. I noticed the particle size was more even, and this density, of the particles was much greater. And even though the material used was much lighter. And what I have to come to the conclusion of is that the high voltage plasma arc creates a lot more colloidals per material over the low voltage DC. Just mentioning the differences that I'm noticing between the two. Still continue to do your low voltage DC. To be perfectly honest, I haven't seen any difference in taking titanium high voltage plasma arc as opposed to low voltage DC titanium, or I haven't seen any difference in my ascorbic acid colloidal platinum formula as opposed to the high voltage plasma arc platinum. I haven't seen any physical difference in taking those, but if I had to say that what was a little bit cleaner, definitely the high voltage AC plasma arc stuff is cleaner, mainly because you're just cooking it with distilled water. You got nothing else in there. I want to try cooking silver with a plasma arc and see what happens, and comparing the pictures of colloidal silver, which is I consider the standard, colloidal to measure everything else by. So I want to look at the difference between a plasma arc colloidal silver and a regular and a low voltage DC colloidal silver. We did the compare in the video of the high voltage AC colloidal silver versus the low voltage DC colloidal silver, which really the main difference there was one was cooked with 10,000 volts and one was cooked with 37 volts. And there really was no difference between those two. But the plasma arc is a different animal entirely, because we're creating colloidals by actually melting the metal and then it going into the solution and being capped by the hydrogen or the hydrogen and oxygen and creating nanoparticles. And like I said, so far, I see that is a much more efficient way of creating colloidals, but I don't see a difference whether they're created with low voltage DC or high voltage plasma arcing. That's my findings so far. We'll see what happens as I, drink the colloidals and test the colloidals, and I do more, experiments with plasma arc. I'm Hermes. This is Reality Creative Video, and I will talk to you again soon.